Hello students, welcome to our chemistry class. See students, we are studying alkenes and alkynes chemical properties. In last class, we have studied so many electrophilic addition reactions like halogenation, hydrohalogenation, addition of water, addition of hypohalous acids, all those things we discussed. Today, I would like to explain ozonolysis reaction. That means addition of ozone with alkene and alkyne simultaneously are studying. So, particularly, what do you mean by ozonolysis means alkene, alkyne on addition with ozone to form unstable alkene and alkyne ozonoids, which on hydrolysis in presence of zinc metal to give carbonyl compounds and diketo compounds. Here one important thing is there. Ozonolysis means addition of ozone and followed by hydrolysis in presence of zinc. In presence of the total reaction is called ozonolysis. So here in this reaction we use zinc metal. If you can't use zinc, then we are getting corresponding carboxylic acids. Why? Because in the absence of zinc, what happens? After ozonolysis, we are getting hydrogen peroxide as a byproduct. Actually, hydrogen peroxide is a oxidizing agent. It oxidizes corresponding aldehydes and ketones into carboxylic acids. So, to avoid further oxidation, we use zinc metal in second step during ozonolysis reaction. This thing you have to remember. And moreover, this is useful reaction. What is this? What is the use? Means by doing ozonolysis or based on ozonolysis reaction, we can able to find out the position, that means location of double bond and triple bond. For example, alkene, we can able to find out the position of location of double bonds in alkenes. In the same way, we can find out the position and location of triple bond in alkynes. Okay, the entire thing we will understand very easily by writing the equation. Write down the heading ozonolysis. Next following reaction, I think it is sixth reaction. Sixth reaction. Ozonolysis of alkenes. Ozonolysis of alkenes, alkynes. We are studying at a time alkenes and alkynes. So ozonolysis of alkenes and alkynes. Write down the heading, students. See, you write down theory. Alkenes, alkynes on addition with ozone molecule, with ozone means O3 molecule, with ozone molecule to form unstable alkene, alkyne ozonoids. Alkene, alkyne ozonoids, which on hydrolysis which on hydrolysis in presence of zinc metal, gave carbonyl compounds. If it is alkene, that can give carbonyl compounds. If it is alkyne, that can give diketo compounds. Nothing but what? Diketo compounds. This thing you have to remember. If it is alkene, it produces carbonyl compounds. If it is alkyne, it produces diketo compounds. Okay. This reaction, no doubt it is electrophilic reaction. It is electrophilic addition, no doubt. Ozone ion addition means that is meant for electrophilic addition. So this reaction is used to detect double position, of double bonds, position or location of double bonds in alkenes, and position or location of triple bond in alkynes. This is the use of this reaction in alkynes. Okay, we use zinc. If you can't use zinc, what happens? The ultimate products are carboxylic acids. That thing you have to remember. So it is electrophilic addition reaction, no doubt, and we use zinc, you are getting carbonyl compounds. Okay, you cannot use zinc, ultimate products are carboxylic acids. So to avoid formation of carboxylic acid, we use zinc. Okay, and what is the use of this reaction? Based on this reaction, we can detect the location of double bond in alkenes as well as triple bond in alkynes. Okay, I write equation here. See, I take alkene. Alkene means, what do you mean by alkene? Double bonded compounds are alkene, you know very well. Alkenes, this on addition with ozone produce what here? See, this is alkene bosonide. Which on further hydrolysis in presence of zinc, what happens? Bosonide cleavage takes place. That means why? Because it is unstable compound. It immediately undergo hydrolysis by capturing moisture from the air. So you are getting C double bond O plus, what is this? C double bond O. Okay. I write reaction for alkynes. So what do you mean by alkynes? Alkynes are nothing but triple bond. This on addition with ozone, you are getting compound like this. See, this is called what? Alkyne. This is alkyne ozonide. Unstable. Ozonides are unstable. That's why it immediately undergo hydrolysis by capturing the water from the moisture. So it undergo hydrolysis in presence of zinc. Here what happens? See, cleavage should be taken place like this. Okay, like this cleavage takes place. Ultimately you are getting diketo compounds. C double bond O. So here bond is there, no? C double bond O. These are called what? Diketo compounds. This is the general reaction, you remember, diketo compounds. Students, you write down. Here the thing you remember, ozone added to the double bond. Where the double bond present, there ozone come and added at that unsaturation site. That thing you remember. So I take different examples. So I take CH2 double bond CH2, you know. Okay, or one more thing you remember, students, you remember please. This I write this reaction in short manner. What is that? C double bond C. This is alkene, no? What do you mean by ozonolysis? O3 oblique H2O oblique zinc. This is called ozonolysis. Total zinc. Nothing but ozonolysis. Okay. During ozonolysis, you can write directly products. Okay, in short manner. So just you can cut off this double bond. Okay, you can put oxygen either of the side. That means ultimately you are getting what? C double bond O plus C double bond. That's all. It is a short reaction. Okay. Then I take one example C for your clear understanding. CH2 double bond CH2. Okay. This on ozonolysis. Actually, on addition of ozone, you are getting compound like this. C CH2O CH2O. This is called what? Ethylene ozonide. Ethylene ozonide, isn't it? This on hydrolysis in presence of zinc. Hydrolysis in presence of zinc. What happens? Cleavage should be taken like this. You are getting what? 2 moles of formaldehyde. HCHO. This is called formaldehyde. Formaldehyde. Okay, this reaction you can write in short manner. What is that? Just you put CH2 double bond CH2 on ozonolysis O3 oblique H2O oblique zinc. Just you can cut here, put oxygen either of this side. Ultimately, you are getting 2 moles of carbon. This is the short way to write ozonolysis reaction. Okay, then I take examples for alkynes. Here I take acetylene. The first alkyne is acetylene or ethane. Acetylene. Okay, which on addition with ozone, what happens? HC. Okay, C. Okay, this is nothing but what? Acetylene triozonide. You know, this is acetylene triozonide. Acetylene triozonide. On hydrolysis in presence of zinc, here what happens? Cleavage takes place like this. You are getting what? HC double bond O, HC double bond. This is called what? Glyaxal. This is called glyaxal, simply represented as G, glyaxal. Okay, glyaxal. So this reaction also you can write in a short manner. You can able to write shortly this reaction. In short manner you have to write. What is that? You just acetylene, you know, this is HC triple bond H. Ozonolysis means O3 oblique H2O, then zinc. Here what happens? See, in place of this bond you are taking HH, no? That means ultimately you are getting what? H C double bond O, HC double bond. That's all. Directly you have to write like this. Okay, students, come on, copy down. Okay, this is the ozonolysis of alkenes and alkynes. But for your clear understanding, and you can write even different products with different reactants. So for that, I give you now. I will explain different examples. See, I would explain here different examples. See here. In case of alkenes, just we studied ethylene and acetylene. Now I take example C, CH3 CH double bond CH2. What is this? You know, propene, you know. Propene on ozonolysis O3 oblique H2O and zinc, you know, just you cut down the double bond side, put either of the side oxygen atoms. Ultimately you are getting what? 1 mole of acetaldehyde here, getting products acetaldehyde, and another one is formaldehyde. That's all. Okay, in the same way here you take, what is that? Same CH3 C triple bond CH. What is this? Propyne. So propyne on ozonolysis O3 oblique H2O oblique zinc, you know, on ozonolysis. What happened here? C double bond O, C double bond O. So this side you take methyl, here this side hydrogen, you know, just you put here CH3 C double bond O, then C double bond OH. This is called what? Methyl glyoxal. Methyl glyoxal. You are getting product methyl glyoxal, shortly represented as Mg. Okay. Here this eliminated oxygen eliminated as zinc oxide, ZNO, minus ZNO. Here also this oxygen taken by zinc eliminated as zinc oxide. So need not to write the what is that byproducts and balancing in organic chemistry. While studying organic chemistry, you don't bother about balancing, and also need not write the, there is no need to write the what is that byproducts and balancing. Then I take another one, C here, CH3 C double bond C. Here CS I take CHCH3. On ozonolysis, what happens? Just you break like this, keep either of the side two oxygen. Ultimately, you are getting what? CH3 C double bond O CS3. You know this is acetone. All of you can know this is acetone. And another one is CH3CHO. This is aspartate. This is aspartate, isn't it? So this is the easy way to write the products on ozonolysis. Now I take here CH3 C triple bond C CH3. This is called. So what is this name of this compound? See, 1, 2, 3, 4. This is 2-methyl 2-butene. Reactant is 2-methyl 2-butene. On ozonolysis gives 1 mole of aspartate and another mole of acetone. Okay, here we are taking 2-butane, you know, 2-butane. Which on ozonolysis? You are getting what? Product like this, CH3 C double bond O, C double bond O, here CH3. This is called what? Dimethyl glyoxal. Dimethyl. Actually, this is glyoxal, you know. In place of H, methyl is there, that's why it is methyl glyoxal. Here, in place of 2 hydrogen, we have 2 methyl groups. That's why it is called what? Dimethyl glyoxal. Short abbreviation and famous abbreviation is DMG. This is G glyoxal, this one is glyoxal, this one is methyl glyoxal, this one is dimethyl glyoxal. Okay, students. Okay. So we are practicing so many examples, so that we got perfection, you know. Then I write another example. You know this is cyclohexene. This on ozonolysis. Ozonolysis means O3 H2O oblique zinc. What happens? Cleavage should be taken place like this. What has put oxygen here? Put oxygen. Then this is called what? CHO, no? CHO. This one is CHO. This is CH2. This one is CH2, CH2. 1 CH2. This is CHO. Okay, this is CHO. So 1, 2, 3, 4, 5, 6. This is actually adipenaldehyde. Adipenaldehyde. Okay, this thing you have to remember. Adipenaldehyde. Okay, in the same way, see, I take another example. Here, students, you remember, you go on writing different reactions, so that what you get more perfection, and you can easily attempt the questions, NEET questions, IIT mains question, even MSc chemistry entrance question, whatever it may be, you should attempt easily. Okay, then I write another example. What is that? CH double bond CS2. This is actually vinyl benzene. This group is vinyl. So vinyl group is present on benzene. That's why it is vinyl benzene. And famous name is there. This is styrene. Styrene on ozonolysis. What happens? So cleavage takes place at the site of double bond. Keep oxygen atoms either on the side. By this you are getting what? C This is benzene CHO, nothing but benzaldehyde, okay. Then HCHO, formaldehyde, you know this formaldehyde, okay. In the same way, all these are very important reactions, students. All these are important, what I put, I marked as a star examples are very important. There is a choice to come entrance exams, okay. I write one more important in ozonolysis: CH2 double bond CH single bond CH double bond CH2. This is 1,3-butadiene, 1,3-butadiene, okay. 1,3-butadiene on ozonolysis, what happens? So that means here double bond present in this compound at two sides. Here double bond is present, you know, here double bond is present. There, yeah, how many double bonds are present? All double bonds undergo addition with ozone. That's why you put oxygen here, you put oxygen here. So you are getting what? CHO. This is this, you know, 1 mole of glyaxal. You know this glyaxal. Okay. Then this is CH2O. That means 2 moles of formaldehyde. You are getting 2 moles of formaldehyde. Okay, students. These examples were enough. We did so many examples. With this, we got perfection. Okay, you write down all these. Okay, for example, here you take, what is that? Cyclohexyl. For example, you can take molecule cyclohexyl. On ozonolysis, here you are getting compound like this, double bond O. This is called what? Cyclo 1,2 dihexanol. Cyclo 1,2 dihexanol. Cyclo 1,2 dihexanol. Okay, students. Like that, you may take compound like this: CH triple bond C triple bond CH. This is called 1,3-butadiene. Which on ozonolysis, what happens? See, H C double bond O, C double bond O. This becomes C double bond O. Okay. Then single bond C double bond OH. It's a very interesting product you are getting here. See, very interesting product, no? very interesting product. Okay, you are getting product like that. Okay, what is this compound? The name is very typical name. You need not write product name, no need. If you want to write, very easy, no doubt. 1, 2, 3, 4. Okay, this is called what? But 1,4 diol 2,3 dione. This is IUPAC name. Dione, 2,3-dione. Or simply it is called what? Glyaxal, you know, this is formyl. Diformyl diformyl glyoxal. Common name is diformyl glyoxal. Okay, but it's very interesting product you are getting by conducting ozonolysis with 1,3-butadiene. Okay, students. Okay, I want to remove this. Okay, see, one top compound we know in organic chemistry, benzene. This is a very familiar and famous compound in aromatic chemistry, benzene. Which on ozonolysis, what happens? O3 oblique H2O oblique zinc, you know. Here what happens? See here, cleavage should be taken place like this. Here cleavage should be taken place like this. Here cleavage should be taken place like this. So ultimately we are getting what? CH bond, CHO bond, CHO. That means you are getting CHO, okay, and CHO. These are nothing but glyoxal. So you are getting 3 moles of glyoxal. 3 moles of glyoxal. Benzene on ozonolysis, getting ultimate product is glyoxal. 3 moles of glyoxal. 3 moles of glyoxal. Okay, students. Okay, with this we completed ozonolysis reaction of alkenes, alkynes. Combinedly we studied. Okay, with this we completed this reaction. Students, I stop here. Remaining part we will continue in next class. Thank you.